All right, so a few things real quick to talk about as I'm handing these out so we can work through them and figure them out. Someone asked, did I watch the presidential debate? No, sorry, I don't feel the presidential debate should be entertainment purposes. I think they should be stick to the issues. They shouldn't badger each other. And doggone it, just for a change, I think some of them should actually tell the truth. Going, yeah, you know what, I made a mistake, or something. But so no, I don't watch the presidential stuff because I've already formed my opinion, and there is a person I'm voting for. His first name starts with an M, and his last name starts with an M, and in the middle of it is Icky and Ouse. So Mickey Mouse is my vote. We'll see if some fictitious character that makes us laugh when we're kids and act when we're teenagers. We can act like we don't like it, but then later when we become adults again and we live vicariously through our own kids, we love it again. All right. So let's talk about these proofs. It's been a few weeks since we've done an actual proof, so let's see if we can hammer these out together. Okay? So let me draw the picture up here. So we have a triangle. We have C, D, that's angle 2, that's angle 1, angle 3, A, D. Is that everything? We good so far? All right, so statement and reason. So let's not lose any points. Let's go. Number 1, we have angle 1 is complementary. Angle 2, that's the old given. Number 2, we know that angle 3 is complementary to angle 2. It's also given. So, review of terms. Complementary means they add up to 90. So I think, what can we state about this? Angle 1 is complementary to 2. Angle 3 is complementary to 2. So what do you got? Go ahead.
Oh, me? Okay. Angle 1 is complementary to angle 3.
I like your thought. I don't think we can say it yet, though. But I like it. What do you think?
Can you say that angle 1 equals angle 3? Because
I do like that.
Isn't it a theorem? It's like 3.
Something like that. Something like angles that are complementary to a same angle are equal to each other. So I don't remember exactly what theorem it was, but I don't. It's trying to come out, but it's not. Yeah.
Did you say it's alternate interior?
Well, I was just trying to base off here. It might be. We might get to alternate interior. I wasn't going to the diagram yet. I just wanted to see if we could get something off this. So, like 1 could be 40 and this could be 50, and that would mean this has to be 40 and 50. So I think we can make the leap to here without a problem. And then some about an angle is congruent to a complement is congruent, something like that. I can't remember the exact terminology, but I think that's enough information about it. So then with that, we know that 1 is complementary to 2. So that means angle 1 and angle 2 have to add up to 90. And then 3 and 2. And so, I don't even know what we're trying to prove here.
A, B,
Oh, so we're trying to prove that this and this are parallel to each other. Is that what we're, okay? All right. So we know that 1 is congruent to 3. I think that's enough information to prove these we have parallel. So step 4, segment CD is parallel to segment AB. And Sawyer, you said what it was?
Alternate interior.
They are alternate interior angles are congruent. I think that's it.
Wait,
Therefore parallel.
Yeah,
for
therefore parallel. Thank you.
the reason for number 3 was what? I don't understand the reason for number
What?
The reason for number 3.
Okay, so being 1 is complementary to 2 and 3 is complementary, it falls under the transitive property. So here's what's taking place. I don't think we have to go there, but this we could say this. So this is totally done. But let me just put an addendum to that. So because of number 1, we could say that angle 1 plus angle 2 is equal to 90. Right? Definition of complementary. And then we could say that angle 3 plus angle 2 is equal to 90. Same reason. And then we could say that angle 1 plus angle 2 is equal to angle 3 plus angle 4 because of transitive. Or wait, 3 and 2, excuse me. And then we could go ahead and say that angle 1 is congruent to angle 3 because of subtraction. And then that takes us in. So this right here has already been proven over and over and over again. So that's technically what squeezes in there, allowing us to make that leap right there.
So for another reason for number 3, could we do transitive? Since you're just putting in.
It's very similar to the transitive property, but it's an actual theorem that we're going with. So this theorem saying an angle is congruent to is complementary to the other. It's complementary to the other congruent angle is basically this whole thing taking place already. This is the reason. So like we've proven a big old clump and mixed it together. Now, here's a question, guys and gals. Are we wrong if we did not go right to the step? What if we put in all of this? Is it wrong? No, it's completely a legitimate thing to do. Okay, so if you don't feel you need to go and make that jump, or you're not going to remember theorem 3.8 or whatever it was, then go with the longer proof. It's totally fine. It's still correct. Okay? But what I would do on this problem is, being I was able to solve this in 4 steps, I would then say this is an 8-point proof. If you added extra information, that's all appropriate. You're still fine, but it doesn't increase your point value because you did more steps. Yeah.
On the test, are there going to be like the proofs that we did before these ones?
I'd say it'd be pretty similar to this.
So like,
I mean, so let's think about this. What would I maybe change on the test on this type of problem? I might do angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 2, which I just changed the term complementary to supplementary, and it might be the same exact type of thing, and it's the same type of theorem that goes along with it. Okay, is that okay? How do we feel? We doing okay? May I move off this one? Go ahead and try that second one while I try and draw it the best I can. trying to prove that C is parallel to D. Okay, so we know that A and B are parallel to each other. They tell us that 1 and 3 are congruent to each other. And they're giving you that they are congruent. What's another step that we could say about two angles being congruent to each other and why?
One is congruent to 2.
Cool. So angle 1 is congruent to angle 2. Why can I say it?
Definition of alternate exterior angles.
Alternate exterior angles. Nice job. Perfect. Okay, so they told us that 1 and 3 are congruent by definition, and then we know that 1 and 2 are congruent by definition. So now what can I say? Go ahead.
3 is congruent to 2.
Why is that?
Because of the transitive.
Yeah, I like it. Angle 3 is congruent to angle 2 because of the old transitive property.
You said consecutive angles.
Yeah.
Not yet. Are consecutive angles.
Yeah.
Are you thinking corresponding angles?
Corresponding.
We're going to say corresponding angles here in a sec. I can't say that yet. I wanted to be able to prove that they're congruent, but we're going to use corresponding angles now because 2 and 3 are corresponding angles with the C and D lines and having line B be the transversal. And so that's actually going to allow us to go ahead and say that step number 5, that C is parallel to D. And the reason I can say that is 2 and 3, these are corresponding angles. Therefore, parallel. So, I'm sorry. 10-point proof. You used more steps.
More points?
Sure, for you, Sawyer, because you need all the points you can get.
Whoa.
Oh, Bert! I'm sorry. I shouldn't have said that. That was so inappropriate.
All my classes are roast sessions today. So
I think the teachers are. Well, I think all the teachers are ready for break. You know, the students, you aren't ready.
Shit, I was ready 6 weeks ago.
I was ready. Someone asked me at church the other day. They said, "Oh, you get fall break?" I said, "Well, yeah. You know, Cherry Creek Schools has. You know, like, oh, well, Douglas County had it this time." It's like, yeah, it's quite, you know, great. Yay. And they're like, "Don't you miss your students though?"
Oh, what? Please don't. Like, don't finish.
Sure, I do. But if you're gonna give me time off, I'm taking the break. And you know, I can't imagine you guys are gonna be walking around break going, "Dude, what are Mr. Stirrups doing right now? I wonder how those vertical angles are." There you go. It's like, yeah, I can't get them on my own TVs. So I had a. So I'm sure you guys are aware. I am the game manager for volleyball and basketball, and then football. I'm on the sidelines to ensure that people have the appropriate field passes because there's a lot of people that, you know, will say, "Oh, well, I know so and so, therefore I'm entitled to," and I say, "Well, I understand, but you don't have a field pass. So if you did truly know this person that well, they would have given you one. So at this point in time, could I ask you to please sit in the stands, and then perhaps the following game, that person that you're so, you know, tight knit with and knows you by name, you know, at the drop of a hat, will then get you a field pass." So that's kind of my job at football games, but then I get to, you know, hang out, watch the game, which I love. But last night was nice because, let's see, Tuesday night I had a volleyball game, so I was here. You know, I got the med class in the morning, and I was kind of looking at this week. I was like, oh my gosh, I got volleyball Tuesday and Wednesday. Oh shoot, man, I'm just like trying to figure out how not to, you know, burn myself out because, you know, when I'm getting here at 5 in the morning and I'm staying here until 8 o'clock at night, sometimes even 9 o'clock at night, it kind of is a lot. But last night, one of my guys who works with me a lot, he used to be a teacher here, but he's now retired. He shows up and he goes, "Did you need me to work tonight?" And I'm like, "Do you want to be game manager tonight?" And he goes, "Sure." And I goes, "Here's the people who are working. Have a nice evening." I was out. So I was able to go home, enjoy soccer practice with my youngest daughter, chat with my oldest daughter, who's now her concussion is she's in the clear. So that's good. So thanks for asking. Okay.
No problem.
Yo.
Is your daughter on like a competitive team? Are you like a competitive coach?
Yeah, so here's the thing. I know soccer very well. And so I started out in the rec when they were this tall and you had like goals about the size of this desk and there was no goalies. And that started out with, I think we had 9 kids originally. And of those 9 original kids, 6 of them still play for us. And so I've coached them from kindergarten till now, 7th grade. And this season, we have snuck in the back door of competitive. So Littleton United competitive kids for the year pay $3,000. My kids pay $800. I'm still that dad who volunteers. And then I get a lot of the competitive. What do you know about soccer? I took a boys' high school team to state.
Was that the one with,
Eddie?
Eddie?
Yeah. Eddie was not on the state team. He was on a few years earlier. Yeah.
Could you tell us Halloween stories for the rest of class?
Halloween, you got it.
Yes.
So here's a scary one. Let's take a look at our chapter 3 review. This is spooky.
It's just one side.
Oh, it's in your books. It's in your books. So let's take a look at that. And let's go through them. And I don't know where, I don't have my book with me, so you guys have to help me on it. So, chapter 3 review. And for Sawyer, we need to make it spooky. We'll make it spooky with the magic pen. Magic pen. Magic pen.
If you circle it and you touch it or something.
Oh, well, yeah, then now it's spooky. Now it's a magic pen. Look at this. It's spooky. It goes and fades away.
Whoa.
So here you go.
Circle that. Whoa. Wow.
What did you?
If you make circles and then I can't find my map.
Oh, but that's so scary. It's a drawing of Mr. Sparrow.
Woo! Has as much hair too. All right. So let's take a look at that very first page of the review. And those of you up front, I need to take a look at yours because I don't know what it is. All right. So chapter 3 review. Is there anything on the front page that you would like me to go over and we could figure out? Lynn? No? Yeah? It's okay. 3C. So, this is it still, right? Is it all these pages? Holy moly guacamole. 3C. Alright, let's get out of the magic pen. Pen 3C. X plus 70, 10x plus 20, and then 60x plus 50. Okay, everything in. Solve for x and then find the measure of angle 1. Okay. Alright, so being we know those two lines are parallel, what do we know? Do we know anything about, what do we know? Like, is this angle here and this angle here anything?
Oh,
Is this angle here and this angle here anything?
Yeah, supplementary.
You know they are.
Yes, because they're parallel lines too.
I agree. They would have to be supplementary, but I can't call it supplementary as they sit. I would state that you know that this angle here would have to be this because of what types of angles would this and this be? They're corresponding. Okay, so corresponding angles are equal, and then we can definitely make the leap that this angle are a linear pair and they're supplementary. So that means that 10x plus 20 plus 80x plus 70 is equal to 180. Agree?
Yeah.
Does that make sense? Is there any part of that you're stuck on? I'm going to combine like terms, so 10x and that, I got 90x plus 90 equals 180. Subtract 90 from either side. So x is equal to 1. All right. So if x is equal to 1, what kind of angle is this and this to each other? They are corresponding. So corresponding angles with parallel lines have to be equal. So if I know that x is 1, how big is this angle going to be? That's 110. And so angle 1 also has to be 110 due to corresponding angles. So Sawyer, I'll make a deal with you.
Yeah.
When you are graduated from high school,
Uh-huh.
we'll go have milkshakes over there at the Sonic, and I'll give you the 3-hour-long version of the Halloween story.
Really?
Yeah.
Yes.
It's that good.
Can I come today?
Today, no. You have to graduate from high school first.
Can I come with you then?
Don, you
So what does that mean for everybody?
Yeah, anybody. Yeah. So what we'll do is like you find me at graduation, go, Mr. Strub, I know we have a cool graduation party. It's the whole family in town. Grandma Edna is like 116. She made it in town. I don't know how, but we're gonna go to Sonic.
Can
So-
I come with you?
We're there.
Sorry, meet up with me at the graduation if we still know each other.
In 3 years, let's do it.
But it'll be awesome.
It'll be good.
It'll be awesome. Oh.
Sophomore. Oh, I hate my life.
Lucas
Oh, I'm
kicked it.
so triggered right now.
I'm hoping it's just coffee, and it wasn't one of you has a colostomy bag and it leaked.
What?
Bag that
It's disgusting.
you think? Looks good. Yeah. It's a little crooked, but we don't judge it. All right. What other problems from the review front page? What other problems from the review front page? Do what? 3B? 3B. Oh, this one was fun. I didn't take them off. No, I got mine still.
Yo, wait, actually, Eugene, give his shoes back. No.
Eugene, give me back my shoes.
Wait.
He flung them at him and
Eugene, I transit for you. I transit for you.
No.
No.
Why should I call?
Yeah, he threw the shoes at him.
No, I didn't.
All right.
Sawyer, get your shoes out of coffee.
There you go.
Eugene, can I have my shoes back, please?
Give Sawyer's shoes back, please.
Eugene, give me my shoes.
All right.
Guys, we're acting like little kids.
It happens. All right. Let's figure out this one. So item number 1, we want to solve for this angle right here. I know that this angle and this angle have to be the same because of vertical angles, but that's not really helping me at this point. So is there any 2 angles that we could set together to be equal to each other? Yes, sir.
3x minus 2 and x plus 4.
Those are equal to each other. What kind of angles are they? What kind of angle is this and this?
Corresponding.
They're corresponding. They have to be equal. So subtract x, that's 2x. Add 2, that's 42. So x is equal to 21. So being you have x all around here, we have enough information to know how big certain angles are. So that means that this angle here has to be 61 degrees. This has to be 61 degrees because it's corresponding. And then how big does this angle have to be then? How big's that angle got to be?
It has to be the same.
25. Okay? Is that okay? So then other things that should kind of stick out a little bit is these three angles form a straight line. They're not a linear pair because it's 3. It's not, a pair is 2. But they are supplementary to each other. So that means that at 25 degrees plus 61 degrees plus angle 1 have to equal, equal 180. Good. And then,
Subtract. I mean, you add and then you subtract.
say what?
You add.
86 plus angle 1 equals 180. Help me out.
And then you subtract.
Subtract what we get.
You get
94 degrees is angle 1. Sweet. So that angle right there is 94 degrees. Cool.
Sam, oh my.
Anything else from that front page? That's a good amount of stuff. Yeah.
At the last 5 minutes of class, can we have a political debate? Oh boy.
Oh.
Yes.
Please.
Only if you use proofs.
Okay, I can do it.
All right. Oh boy. All right. The second page, the back side. 5B. That's a good one. 5B.
I know. That's just like.
All right. Oh, wait. Find X and Y. Okay. We want to find X and Y. Cool. Shh. So these two angles have to be what and Y? They're not complementary. Supplementary. Why?
Consecutive interior.
Consecutive interior. So that means that 2x minus y plus 60 equals 180. So let's modify that a little bit. So that means this. Yay?
Yeah.
We feel okay with that? So this is one of the equations I'm going to use. It's a little cleaned up. And then what do I know about this angle and this angle?
Supplementary.
The supplementary, what's the reason?
Consecutive interior.
Consecutive interior have to equal 180. Okay, so then we'll clean that one up as well. So those are the two that I'm going to use. What's nice about if I use those two and we want to use a little algebra on it?
Elimination.
Elimination works nicely. So if I add these two together as they are right now, I'm going to get 4x. The y's are gone because they're already opposite value. Equals what? To what? 230? And then I need your help. I can't do this in my head. 57.5. Shh. So 57.5 degrees is that. And then we're trying to solve y as well. So what's 50? Let's see. So that means I can go 2x minus y equals 120. I know that x is 57.5. 120. 2 times 57.5. Help me out. 115.
You stop talking about politics.
And then subtract 115. So your negative y is equal to 5. So y has to be equal to negative 5. There you go. Your x value is this. Your y value is that. And you're good. That's a good problem. Set it up as a system. Anything else from the back of the first page? Front or back?
5A.
5B, we did. 5A. So for x and y, 5A. X, y, 45. Okay. Here we go. So sometimes on these, by filling in things you might know might help you out. Like if you know this is 45, this has to be 45 because they're vertical angles. I don't know. That might have helped. I could also probably say that this is the same thing as this right here, and this angle here is the same as this right here because of vertical angles. I don't know if that really helps us or not. Yeah.
Did you say that y is 50 is corresponding?
Yes.
Okay.
Yes. So this is also 50 because of corresponding angles. Good job. Then, so if that's 50, then that means that has to be 50, right? And then this is a straight line, so 45 and 50 is 95. So I got 180 minus 45 minus 50, which is 180 minus 95, which is 85. 85? Sweet, 85 degrees. Love it. 5B we just did. Right there. So the front, the back, anything there on the front, the back? Any more on the front, the back? How about the front, the back, the front? Front, the back, the front. I did hear this morning on the news, and then I opened up my ballot to verify it. There are 22 people running for president on my ballot. Wow. I have a feeling that a few of them might not be qualified. Not mentioning any names, but I'm just saying. Of the 22, there might be a few of them that aren't qualified. I'm just saying. 22 people running for president on the ballot. On the Arapahoe County ballot, which is this county. 10D? Yeah. Write an equation for each line in slope-intercept form. Okay, so I want perpendicular, so this is 10D. So I want y equals negative 3x minus 1 passes through this point. Okay? All right, so this is already set up in slope-intercept form. So my slope of this line is this. So the perpendicular slope has to be 1/3. Agree? And then realize the point slope form. So that could be x1, y1. And I can do y plus 2 equals 1/3 x minus 9. Did it say just equation or did it say
Write the equation of each line in slope-intercept.
in slope-intercept form? Okay, so if we do this in slope-intercept form, that means I'll distribute here. 1/3 x is 1/3 x. 1/3 times 9 is negative 3. And then I'll subtract 2. So this line here, this equation here, is perpendicular to that equation. This line also contains that point. Front, back, front, anything. 7B. Ooh. 7B, proofaroo. That's a good one. Chew. Okay. I can tell you something politically I put on Facebook the other day.
Go.
So I'm a Facebook nut. I use it for purely entertainment purposes. and nothing I've ever read on Facebook has ever influenced me in any way, shape, or form. So I put on Facebook, has anybody read a Facebook post that has changed your vote? Question mark. And then I put, me either. Boy, you should see some of the comments I got from people that say they're my friends. I think I need to unfriend them. Some of them saying, I get all my information from Facebook and I have changed my vote because of, and I'm like, oh, I just think this person was halfway intelligent. So, yeah, I got a lot of people, and then, it's funny because when you get the comments and then the comments to the comments, that's always good. Like, who is this person? They're stupid. It's like, yeah. All right, angle 1 is complementary to angle 3. Angle 2 is complementary to angle 4. This is not going to allow us to do that one theorem because we don't have a similar thing there. But what I probably could get away with is this.
Hey.
Why? Vertical, good. Okay, so that's going to work there. And if that were to work there, that means, hang on, I think we could do this. Hang on, we could do this. So I'm going to use this step and then steps 1 and 2. So I have to pick one of them that I want to use. So maybe I can say that angle 1 is complementary to angle 4. What did I just do?
Substitution.
Substitution, I like it. Okay, so I utilized the vertical angle that I figured out, and now this is going to help me out because this and this means something. What can we state about that now? Oh, wait. Is that what I wanted to say? What? Say that one more time. I didn't hear what you said. Yeah, so then what's my next step? Well, so I'm going to look at this and this, yes? No, not complementary. 1 is what? Angle 1 is congruent to angle 2, and that's that reason of definition of complements to each other are equal. Angles that are complementary to the same are congruent. Something like that. And again, I don't remember exactly what theorem. Some of you might put that. It's theorem 3.8. I don't know what it is off the top of my head. So something like that is a totally legit reason. So now we know that this and this are good. BD is the transversal AB and DC. So what kind of angles are 1 and 2 at this point? Alternate what? Alternate interior. So now we can go ahead and say that AB is parallel to DC, or CD, whatever we want to say. Number 6. This is definition of alternate interior angles congruent, therefore parallel lines. That totally works. Oh, I like it. I don't think there's a way that we could necessarily take that much or do that many less steps. So I'd say that'd be definitely a 12-point proof. Does everyone see why you can't take the 1 and 2 and change it to how we had done earlier on the original sheet that I handed off? So those are just some things to think about. Okay, but I like it. It's good. All right. Anything on the rest of the review? Rest of the review you want to take a look at. Yeah. 12? Yeah. Good. Number 12. I love that you take care of me. Makes my job so easy. Ooh, this is one of the dorky ones we worked on the other day, right? we want to find the distance from this point to this line. Yes? All right, so, and I like making a picture because sometimes it helps me because I'm not that bright of a person.
Is this like the 4 problems that we did yesterday?
Uh-huh.
Okay.
So here's our point, and then we have a y-intercept of -7. And I'm going to go up 3, right 2. So we want to determine this distance here, and the closest distance has to be perpendicular. So does everyone feel that we could probably say that this is going to be a number that's bigger than 1? And it might be bigger than 2, 3, or 4, or even 5. But this is a number, it's not going to come out to be like, 0.26 or something like that. Does everyone feel comfortable with me saying that, how I have it drawn?
Yeah.
Does that make sense? All right, so what I need to do is I need to figure out that point there. We have a point in common right here. I don't know what that point is at this point in time, but I know that this green line has to have a slope of -2/3. Why can I say that? Yeah, it's perpendicular. The purple line is 3/2, so the slope of the green line is that. So then we have this point out here. So that's a point, and I know our slope of this green line will be perpendicular. So let's use our point slope formula. And I'm going to call that x1 and y1. And so I have y minus 5 equals -2/3 x plus 5. Did I do that correct? And if you have a calculator, this would be a good time for you all to use it because I'm going to start getting goofy with math because I can't do real fancy stuff like that. That's what, -10/3, is that right?
Yep.
And then y equals -2/3 x. -10/3 plus 5 is what? How much? 5/3?
No.
Yes, you're right. It is 5/3.
Because
That would be 15/3 if I added it over there. Right? Because I'd put that over 1 times 3 times 3. That's 15/3. If I add 15/3 over there. So 5/3 is 1 and 1.6 repeating, roughly. We good? Emma? Good. Okay. So then I could take my new equation here and my original equation here, and I have to set them equal to each other. When I set them equal to each other, what I'm trying to find is I'm trying to figure out what that common point is right there. So if I set them equal to each other, I'm going to be able to find that point. So I'm going to get 3/2 x minus 7 equals -2/3 x plus 5/3. If I didn't like having fractions, what would be a good number to multiply all 4 terms by to get rid of all fractions? 6. What do you think? Make sense? I have a denominator of 2, I have a denominator of 3. The smallest number that 2 and 3 have in common is 6. So I'm going to multiply this by 6, this by 6, this by 6, and this by 6. So that's 18/2. So that's what, 9x minus 42 equals, what is that? 84x? -4x. That's a holy cow. And that's 10. Sweet. Now we don't have any denominators to worry about. They're not going to get in the way of stuff. This is a really good skill to have. So I'm going to move that over. It says 13x. And then I'm going to add the 42. So that gives me what? 52. So x equals, what's 52 to 4?
Yeah.
Exactly?
Yep.
Oh, that's good. That's right. Would this make sense that this is at 4?
Oh yeah.
Okay. What's my last step?
Plug it in.
Plug it in. So I can plug this value here, or here.
First one.
Okay, the first one looks better. So y equals 3/2 times 4. That was an x. Minus 7 So y equals 6 minus 7, which is -1. Does this appear? I mean, we're off a little bit, but they're telling us that this is the point 4 comma -1. Okay, I might be off on my drawing a little bit, but can we make it work?
Yeah.
Okay, so now I want to know how far 4 -1 is from this right here. Okay? Now, so different minds think differently sometimes. Some people want to use the Pythagorean theorem in order to determine how far the distance is. And the Pythagorean theorem, if you derive it, you can get the distance formula from it. Happy to show you the proof of that one day if you'd like to see it. But I just like to go right to the distance formula, which is this. Okay? And then we already have x1, y1, so we'll call this x2, y2, excuse me, I got the hiccups right now. So x2 as I have as 4, minus 5, so 4 plus 5. Plus y2, we have what? -1 minus 5. So that's 9 squared, which is 81. Plus 36, and 81 added to 36 is root 117. Is that right? And what's the square root of 117?
There isn't one.
Huh?
There isn't one.
Okay, what? Yeah, calculator. So give me three decimals. 10 point.
Was it 8 or something? 10.816.
10.816. Hey, remember what we said originally? Does this distance look like it could be a number like bigger, 1, 2, 3, 4, 5? Yeah, it's actually 10.8 as that distance. So cool. That's a great problem. I really love these problems. This is like some of my favorite stuff in this class, this kind of problem. So, it's up to you. The answer should be there, right? If I were you, I would say definitely take a look at that this evening. And then come tomorrow, we have our quiz, our test. There probably won't be a whole lot of time that we could spend in class talking about the math. So if you do need extra help, come find me in my office. If not, have a great day. I won't collect the report. All right, you guys are getting recorded. Say hi to the camera.
Wait, what?
Hi,
Wait, so the
camera.
computer's
How you
recording?
doing?
Yes. All right, so
No, I'm gonna.
I
be
have
as
already
quiet as
done
possible.
7B, so that's already recorded. So 7A.
I want you to be quiet. Don't agitate me.
Hello, Internet.
Don't force me to. I forgot the phrase. Don't force my hand.
Force his hand.
No. What? Oh jeez.
I'm gonna go now. I'm happy.
We want to prove those are parallel, right? So statement, reason. So step 1, put our givens. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Those are both given. Is that all right? So with that known, let's see, 1 is congruent to 2. So 1 is congruent to 2. And then 3 is congruent to 4. Oh, I could definitely say this, though. I could say that angle 2 is congruent to angle 3. Why is that? Because vertical angles. And with that then known, I could then say that that the lines are parallel. All right, so what I'm going to do is I'm going to pick this one. I'm going to pick that one, and I'm going to modify it to this. I want to do angle 1 is congruent to angle 3. I used these two to get to that step, so what did I do? Transitive? Yeah. Good. So then I could say that if that's the case, then I can then use this modification here. This and this. So that's going to allow me to say what with transitive property? The green and the green. Angle 1 is congruent to angle 4. That's also transitive. And angle 1 and angle 4 are a slick looking pair. So then I can say that AB is parallel to CD for what reason? Huh? Alternate interior angles. Congruent. Therefore, parallel. Cool. Yeah.
I have one more question. 5B.
9B. So you have a line. Let's see.
I really want the thumbnail to be you just in the frame.
Okay, find the unknown coordinate. So this is one of the problems. You have to remember the slope equation. So slope equation's this. Hello, camera. Ow, I think I just broke something down. X1, Y1, X2, Y2. Oh, God. All right.
I really have to leave that in there.
He doesn't. You don't
He doesn't
edit your
edit his
videos at
videos.
all, really, right?
Ow. So we got that so far. Is that okay so far, CJ? So then I got 1/2 equals y minus 4 over 7. Cross multiply, so 7 equals 2y minus 8. Is that okay if I do that? And then that's what, 15, 2y, y equals 15 over 2.
Can you
Or
please make that
7.5.
picture of me as a thumbnail?
You got it.
Oh, you were gonna do that one thing
One thing.
for the edit.
I can tell you, in my Algebra 1 class, there's a bad word that's on the video.
Oh
Who said it?
I didn't say it. I
know your
wrote it
video could be
accidentally.
removed for
You
that.
wrote it?
How do you accidentally write?
You're going to have to watch. The video's posted 10 minutes in.
Which one?
Can I check?
You have
Today's CP Algebra 1.
Today?
Is it today?
Yeah, should be in there today.
Well, everyone's